Thank you. Good morning, everybody. My name is Peggy Gunkel Grillon. I'm from the University of New Caledonia, and I work in the Institute of Exact and Applied Sciences. And my talk today is about effects of long-term raw pig slurry inputs on nutrients and metal contamination of tropical volcanogenic soils in Uvéa Island. Before starting my presentation, I just want to say a few words about the institute where I work. You can visit the website to get more information. Sorry, but there is no English version yet, but an English version will be available very soon for the website. So we're a pluridisciplinary team gathering 34 researchers, 8 engineers and technicians, and 18 PhD students. We work on data sciences, biology and biomolecules, matter and environment, ecology and dynamics, and geosciences. And this week, my colleagues are moving in this new building, and we are going to have very new and modern laboratories. So you're very welcome to come and work with us in this very nice environment. So the context of the study. In the Polynesian culture, pig breeding plays a major role in the political, economic, and socio-religious system. On these pictures here, you can see that social events like weddings, funerals, communions are underlined by pig offerings, and pigs are cooked in traditional earth ovens. It means that inhabitants have pig breeding near their family houses. Of course, many studies have been conducted in industrialized countries and demonstrated the negative effects of intensive digested pig slurry spreading for fertilization. Pig slurry spreading induces an increase of nitrogen, phosphorus, and heavy metals content in soils and in surface or groundwater. You can see on these pictures that water eutrophication is the most visible consequence of soil nitrogen and phosphorus overload. In small tropical islands are far from industrial pig productions, since family pig breeding is of concern. But raw pig slurry is spread directly onto the soil without any treatment. The pig slurry is not digested and is not managed. The question is then, does the absence of pig slurry recovery induces a major risk of soils and then water pollution? Before this study, and as far as I know, there were no data available for family farming conducted without pig slurry management in small Pacific islands. And the problem is that tropical soils can be naturally rich in heavy metals, and pig slurry inputs can significantly modify soils' physicochemical properties and then alter metals' mobility. The other problem is that the water resource is particularly sensitive to surface inputs, and contaminants can percolate and reach the groundwater reservoir. The scientific issues are to evaluate soil's physicochemical properties after a long-term application of raw pig slurry. It's also to evaluate if pig slurry input influences the mobility of heavy metals, and then to evaluate if there's a risk of water pollution. we decided to work in Uvéa Island, which is a French territory. The number of pigs was estimated to be between 2 and 15 pigs per inhabitants. These data are a little bit old, but there were no more survey after that. So it means that the number of pigs was estimated to be 18,000. We decided to sample three sites because there are 3 volcanic units. It means that there are 3 different soils in this island. We sampled mixed calcareous soils in the north, and also inland ferrolitic soils. We also decided to compare 2 pig breeding systems. The first one, for the first one, pigs are enclosed in small concrete pens. It means that there's a high pig density, and the pens, the concrete pens, are cleaned every day with a lot of water. So this scenario is it's not a good scenario because with the high peak density and with the use of a huge amount of water to clean the pens, there's a high risk of contaminants percolation. The second pig breeding system was pig enclosure in large land pens with a low peak density, and this scenario represents a low risk of contaminants percolation. So we analyzed the total phosphorus and total metal content and also total nitrogen in pig slurry and in soils. We also analyzed the exchangeable content of phosphorus and exchangeable content of metals, and also the content of nitrates in soils. Why is it important to discriminate total and exchangeable nutrients or metals? The total nutrients or metal are the reservoir. Elements, nutrients or metals can be adsorbed, precipitated, included in organic matter, or included in soils particles, but all these elements are not mobile. Some of them are not mobile at all. And if we focus on the exchangeable fraction, exchangeable nutrients or metals, which are mainly elements adsorbed onto the surface of soil particles, we focus on a fraction easily mobile. Pig slurry input can increase the reservoir of nutrients, the total content, but also modify the mobility of elements. And the percolation risk of elements is high when we consider the exchangeable fraction. When it rains, the elements, here for example metals, can be solubilized, can go into the water of soil, into the soil water, and then can percolate and reach the groundwater. But we also have to study the reservoir because due to the soil's particles aging, the reservoir can provide again exchangeable elements, and so on and so on. So we decided to study the reservoir and the exchangeable fraction. To assess the soil contamination, we decided to calculate a contamination factor and a pollution load index. The contamination factor is the ratio of the concentration of an element in an impacted soil to the concentration of the same element in the control. In the literature, the enrichment is considered as moderate if the contamination factor is between 1 and 3. It's important if it's between 3 and 6, and it's considered to be very high if it's up to 6. The contamination factor was calculated for the total metal concentration to estimate the increase of the reservoir, and was also calculated for the exchangeable concentration to evaluate if pig slurry input has an influence on nutrients and metals mobility. The pollution load index was calculated taking into account 7 elements: iron, manganese, aluminium, copper, zinc, chromium, and nickel. And if the pollution load index is up to 1, it indicates that heavy metals pollution exists in soils. It means that the overall reservoir for these metals is increased. Now some results. So if it's dark blue, it means that the enrichment is very high. If it's light blue, the enrichment is moderate, and if it's white, there is no enrichment. For nitrogen, phosphorus, and potassium, you can see that there's a high increase of the reservoir, and that these elements are exchangeable. It means that there's an important risk of percolation and then an eutrophication risk. On this kind of soil, we're on a calcareous soil. About heavy metals, the reservoir is really enriched for copper, zinc, nickel, is also enriched significantly for aluminium and chromium, and slightly enriched for iron and manganese. But even though the reservoir is not highly enriched, these elements are really mobile because they are highly concentrated in the exchangeable fraction. It means that there's an important percolation risk for these elements. Nickel and chromium in this kind of soils are not mobile at all. And if we calculate the pollution load index, it means that a pollution exists and most of the elements are exchangeable and are able to move in the soil. The results for inland phreatic soils, it's less dark than previously. So about nutrients, there's also an enrichment of with nutrients, but phosphorus is not mobile. But it is well known that phosphorus is not mobile in phreatic soils. So there's a lower eutrophication risk than previously. And if we consider heavy metals, you can see that the reservoir is only slightly increased for these metals. It's not increased at all for iron and aluminium, but only copper and zinc are mobile. Donc there's a percolation risk only for copper and zinc. And taking into account all these results, the pollution load index is only slightly up to 1. The overall reservoir of heavy metals is slightly increased. Is there a risk of groundwater pollution? This is a cross-section of Uvéa Island with the south of the island, the north of the island. The first site I studied was here. So for coastal calcareous soils, metal pollution exists, and there's an important risk of percolation. And the problem is that in this part of the island, at the periphery of the island, the soil thickness is very small. So it means that there's a risk of water pollution. For inland phreatic soils, there's a low metal pollution, and an important risk of percolation, but for 2 nutrients and for 2 metals. And the 2 metals, copper and zinc, are not really detrimental. It's not chromium. So when the soil thickness is very small, there's a low risk of water pollution. But when the soil thickness is wide, this is the second studied site and this is the third site I studied, there is here no risk of water pollution because the soil thickness is wide and is not really permeable. So the question now is, where are located family pig breedings? You can see on this map all these points of family pig breedings. You can see that most pig breedings are located at the periphery of the island, so where there is a mixed calcareous soil and where the soil thickness is very small. So most pig breedings are located where there's a high percolation risk of nutrients and heavy metals. So my conclusion is that there's a high risk of water pollution due to the pig breeding's location. This study highlighted that nutrients and metals enrichments and mobility depends on the nature of the soil. Most inhabitants and then most pig breedings are located where there's a high percolation risk and then where there's a high risk of water pollution. I couldn't go further on the details, but the results for pig breeding on concrete pins induces higher pollution load index values for nutrients and metals, and these elements were more mobile than the results obtained for pig breeding in large land pen. So based upon these results and for groundwater preservation, it is then recommended to limit pig breeding on concrete pins without pig slurry recovery on the coastal area. And for a sustainable pig family breeding, I would recommend to use large land pens on inland phreatic soils, and I would also recommend to use rotating pens. Yeah, to have pigs for few years in an area and then to move the pig if you want to, if the inhabitants want to stay to keep the pig breedings in the coastal area. So these are my recommendations. If you want to get more details, you can see this this publication. Thank you very much for your attention. Oh. I forgot to thank the French Overseas Ministry for fundings. All the inhabitants of Uvéa Island for their